Here's how I designed and built a working Rover prototype from scratch as a high school senior, starting with zero experience in 3D modeling or electronics. I'm Nick, and in this video, I want to share with you the development process behind this project in the hopes that it inspires you to take on a new project outside of your own experience, just like I did. But first, let's go back 4 months to when this journey started. It was the summer after junior year, and I knew I wanted to start another CS project, something out of my comfort zone. I was inspired by Professor Boots on YouTube and his awesome 3D printed RC vehicles, and I thought, hey, I wonder if I could build that. And over 200 hours later, I did. I love sci-fi, so I knew early on that I wanted to build some sort of Mars rover. Here's some of the images I used as inspiration. My main goal was to build something that would be functional, but also look aesthetic and look like it could work in a real environment. And so one of the things I wanted to make sure I did was have full independent suspension with 6 wheels. I bought a 3D printer and taught myself how to model parts in Fusion 360 and just got to work, first figuring out the scale and then building modular components for the drive axles. Up next, the electronics hardware. I had no experience going into this, so I did a bunch of research and tried designing my own PCB, but they say your first one never works, and yeah, they're right. Definitely learned a lot of things the hard way. But unfortunately, I got charged a ridiculous amount on tariffs for those boards, and I had to switch over to a pre-designed one. They're way more expensive and more complicated than what I'd need, but after switching through 2 different boards, I finally found one that worked for my use case. The final board was just slightly too wide in order to fit in the old chassis, so I redesigned that and added more cool details. So the PCB is designed around the ESP32, and the goal was to control it with a PS4 controller, but I found out pretty quickly that both devices actually use different Bluetooth versions, so they can't directly connect. The workaround for this kind of ballooned out of control, so here's how the system works. So I used my phone to tether the connection between both devices since it supports both Bluetooth options, and I developed an app to process the controller signals and send out control packets to the ESP32. And the app can also receive telemetry packets from the ESP32 that contain the gyro angles. That was a feature on one of the earlier boards that had an inertial measurement unit on it. It's not there in the newest PCB, but the framework is still there to add it back. On the ESP32 side, everything runs in C++ with a real-time operating system package, which allows multiple threads to run simultaneously to manage the lights, process the packets, maintain the Bluetooth connection, and control the hardware. The code caches and splits up the control packets to update the hardware and prepare for the next input as soon as possible. And there's a system to manage the 4 drive motors independently to mimic a differential and to limit slipping during tight turns. I'm sure you're tired of hearing me talk, so hit the montage. Here's a quick suspension test with a 10-pound kettlebell. Thanks for watching. I appreciate you sticking all the way to the end. I'm happy to be able to share the development process with you. This project gave me a lot of experience in electrical and mechanical engineering, some systems design, app dev, and video editing, and I hope this serves as inspiration for someone. If you're ever on the fence about starting a cool idea you have, just go for it. I mean, 4 months ago I didn't expect to get this far, and look, here I am.